Hello and welcome to this clip having a look at an exam question that covers Group 7 and gas moles together. So first of all, let's look at how to process the question because there's obviously quite a lot of information provided. First of all, it mentions calcium hypochlorite in inverted commas. This is an old style naming. Don't worry about it. Obviously, later on in the question, in a part that we won't be looking at in this video, they'll ask you to actually come up with the systematic name for that compound. All you need to treat it as is calcium with ClO in brackets and then a 2 like it has in the equation or the formula there. So the next thing is it says that 420 decimeter cubed of chlorine is measured at room temperature and pressure, which means V equals 24N obviously. An excess of calcium hydroxide means that you don't have to worry about the number of moles of calcium hydroxide in the equation because you have more than you need. So this number 2 here, where I'm highlighting it, is not relevant. Okay, the concentration of calcium hypochlorite is what they're after, and they want it in moles per decimeter to the -3. So you use C equals N over V, so you're rearranging N equals C times V so that concentration is the subject. And as you can see, there's 4 meters cubed of solution. It'd be easy to miss that, so you need to convert that to decimeters cubed, so you can put decimeters cubed into your V equals 24N. So therefore you use 4,000 decimeters cubed. The number of moles is going to be the moles of calcium hypochlorite. And finally, they want you to give your answer to an appropriate number of sig figs. So having a quick look at everything, you've got 420, which is 3 sig figs, and 4.00, which is also 3 sig figs. So from the data given in the question, it's all in 3 sig fig format, so you give your answer as 3 sig figs. So let's now put the answer together. Okay, taking the part of the question that we need, I'm going to put the equation at the bottom and use the data moles equation moles answer technique. So putting in the volume of chlorine gas that we're given, and I rearrange V equals 24N to make N the subject, that gives me 17.5 moles. From the equation, the ratio between chlorine and calcium hypochlorite is 2 to 1, so therefore the number of moles of calcium hypochlorite must be 17.5 times a half, which is 8.75. To get my answer, which is the concentration, I rearrange N equals C times V to make C the subject this time. So my N is my 8.75 moles, and my V is my 4,000. So C equals N over V. And that gives me this number, 0.002187 from my calculator, which I need to convert to an appropriate number of significant figures, which we decided earlier was 3, and in standard form, so it's 2.19 times 10 to the -3 moles per decimeter cubed. So quick mark scheme check shows that we're on the right track with that. And if you use the ideal gas equation, they let you have all 3 marks provided a sensible pressure and temperature used, such as 100 kilopascals and 298 Kelvin as standard temperature and pressure. So it leaves you with a fairly similar answer. Okay, hopefully that's been a useful look at this little question. Thanks for listening as always. Until next time, see you soon.